Hello and welcome to week 3. You can see the topics I'm going to cover with you in the videos that we do for this week. I'm going to start by talking about addition and subtraction of polynomials, and then we'll go on to multiplication and division. So let's get right to it and let's talk about addition and subtraction. First of all, we need to know a couple of terms, one being term. And a term is basically, you'll find that it's separated by addition or subtraction. So it can be a number, a variable, or a product of numbers and variables, or a quotient of numbers and variables. A monomial is just one term, and a polynomial is more than one term. All right, so if we were looking at the terms of this polynomial, I can see 3 of them. 7p to the 5th is the first one, negative 3p to the 3rd is the second, and 3 is the third. Remember, the sign of a term is the sign of what's in front of it. If there's nothing in front of it, because it's the first term, it's assumed to be positive. And if we have one term, it's called a monomial. 2 terms is a binomial. 3 terms is a trinomial. We really don't have names for anything bigger than that. The degree is an important concept you're really going to use a lot when you get into Math 1005. But the degree is just the number of variable factors in that term. So for A, you see we have 9x to the 5th. That means there's 5 x's. So the degree is 5. The degree for B is 1 because remember, if you just see a variable with no exponent, it's an understood 1. It's an understood first power. And for C, there are no variable components to it at all. All right, so the degree is 0 because that's the same thing as saying 9x to the 0. We talked about that last week. Anything to the 0 power is 1. Okay, so 9 times 1, that makes sense. So the variable exponent is x to the 0, 0. You don't have to think that much. Basically, if you don't see any variables at all in a term, the degree is 0. Okay, the coefficient is just the number in front of that term. And if you look at that y term, there's no number in front. That coefficient would be 1 because it's an understood 1. Now, if you are asked to find the degree of the whole polynomial, you have to find the degree, the largest degree of the term. So the degree here is 2, 3, 4, 1, 0. So the largest degree listed there is 4, and so the degree of the whole polynomial is 4. Now, combining like terms is one set of directions you'll see for addition and subtraction. It's also the same. If you see addition and subtraction, it's the same thing. It means combine like terms. It's all the same thing. What you need to remember is that we can only add or subtract like terms. And I've said this before. It's something really important that you need to know. You can multiply and divide anything, but you can only add or subtract like terms. And a like term means it's got the same variable raised to the same power. So for example, A, I can go ahead and do 4 minus 9 and get negative 5, and it would be negative 5y to the 4th. So when you're combining like terms, which is the same thing as addition and subtraction, remember that what you are doing is keeping the variable in the exponent, okay? Once you've established their like, and then you can go ahead and add or subtract the coefficients. For example, B. All right, so B is kind of a vision test, isn't it? I mark these up when I'm doing them. So what you see me doing here is what I really do. I'm looking for all the x to the 5th terms. We've got those two, so I can combine those two. 7 minus 6 is 1. Do you see any other x to the 5th terms? I'm looking. Nope. So x to the 5th is that. And now I'm going to look at just the whole number part I've got, or whole number fractions, whatever. Something with no variable component. I've got a 9, I've got a negative 13, so 9 minus 13 is negative 4. All right, now I think I'll circle. So I'm looking at x squared terms. I've got 2 of them. So 3 plus 6 is 9x to the 2nd, and I did it. So that is my final answer, what I'm pointing to right now. That is what we get when we combine those like terms, and I really do encourage you to mark all over your paper, do it on scratch paper. It'll help you not miss anything. And remember, it's good to have them in ascending or descending order. That's why you see the answer to that, x to the 5th, x to the 2nd, x to the 0. In descending order, that's proper form. Now, if you're asked to evaluate, it just means for whatever variable they're giving you, substitute that back in. So we're told that x is -3, and I'm going to put that value in place of the expression. And every time I see an x, I'm going to put a -3. That's what I did here on this very first step. Okay. What you should see now is something that is just the order of operations. So if the order of operations is confusing to you at all, ask me for resources. I can give them to you. Frankly, if you do a Google search for the order of operations, or if you look in Purple Math for the order of operations, you'll find a lot of great stuff and a great review. But we went ahead and did, remember we do parentheses first, which there aren't any. Exponents, we do have those, so we took care of the exponents. And then multiplication and division left to right, addition and subtraction left to right. That's how we eventually got 22. But if you have questions about this, make sure you ask. Okay, and you can even have a word problem. So here we have a soccer league with n teams, and each team plays every other team twice. And the total number of games played is given by the polynomial n squared minus n. So they were kind enough to give us that. And if the boys soccer league has 12 teams, how many games are played if each team plays every other team twice? Well, all we have to do is replace 12 for n inside that polynomial, and then it's just the order of operations, and we get 132. So it looked like a scary word problem, but it wasn't. And this one isn't either. I like this one too because I think insurance companies do use models for coming up with their rates. So if the average number of accidents per day involving drivers of age R, we don't know what the age is, that's what is variable, right? That's what will vary, can be approximated by that expression you see there. Find the average number of accidents per day involving 25-year-old drivers. This is just a fictitious example, so this is not anything for or against 25-year-old drivers. It's just an example. But if I replace R with 25, and that's the only hard part about these, I think. If you feel good about the order of operations, the only hard part is remembering what the variable stands for. So if R is 25, I just replace the expression with 25 every time I see an R. And you see we come up with an answer of 289. So for whatever region this represents, there are 289 accidents each day involving 25-year-old drivers. And that's information that's pretty valuable when setting rates, if it were true. All right, if we were going to add these two polynomials, I really don't have to have those parentheses there, but they're there to show you the two separate polynomials. All you have to do is combine like terms. So I can add these two. I can't add this with anything because there's not another x term in the whole problem. I can add this with this. And then this x squared term, I can't add that with anything because there's not another x squared term. So when I put everything together, this is my final answer. So it's really, the math is pretty simple. It's just a vision test. You're looking for like terms, mark it up if you can, and it's not too bad. So lots of examples are in the PowerPoint presentation. I don't typically do it this way, but I have this for you to look at. If you, in this case, we had 3 polynomials to add. And what we did was we just lined up one polynomial under the other, where like terms are lined up, and that's pretty simple. So feel free to do it that way if you'd like to, just because, and I'm really visual. I don't know why I don't do it this way because it's great, but I'm visual. I don't do it that way, but I circle and underline and stuff like that. Use whatever is helpful to you. Just make sure you always show your work, but use the method that works for you. Remember, the opposite of a polynomial just means we're doing the additive inverse, which is the same thing as multiplying by -1. So if I wanted to know how I could simplify negative, all that stuff in parentheses, all I'm doing is distributing basically a -1, let me get my pen here, through to every term inside the parentheses. And what that really does is just change all those signs to what you see here. So very simple, but you just have to watch because it's easy to skip a term or something. So when we subtract, all we have to do is distribute like we just did and then add, so we don't have to learn anything new. So the trick is changing all these signs. That's what this negative out front does. Doesn't affect the first set of parentheses at all. We change all those signs and that gives us this line right here. And then we take our colored pens, whatever we have to do, to find like terms, and we add them, and you see our final answer right down here. So any questions? Remember, if it looks like I'm going too quickly in this video, you've got the PowerPoint you can download and you can go through it a little bit slower, and then you can ask me if there's something you're stuck on. Okay, same idea, we're just distributing, so you see some examples. And a reminder to change the signs, same thing, you're just distributing. I don't typically use the method you see at the bottom because I'm too nervous about getting the signs wrong. So for subtraction, I don't line things up at all because I'm afraid I'm going to forget to distribute that negative. But if you distribute that negative first and turn it into an addition problem, you're going to be fine. All right, now let's look at a word problem. Let's say you have a 7-foot by 5-foot hot tub and it's installed in an outdoor deck that measures W by W. All right, so why W by W? Because we're going to be able to use this computation for more than one situation. All right, so find a polynomial for the remaining area of the deck. So if you're a manager at Home Depot, you're going to figure this out for somebody. It is really important that you can kind of visualize this. So you can see in the diagram I've got the whole deck, W by W. I'm going to cut out enough for the hot tub, and I want to know how much deck is left because I think I'll redeck that too, right? So what we want to do is find the area of the whole deck and subtract the area of the hot tub. And that's what I do with every word problem I get. I really do. I think to myself, what's the plan? And then I'll execute it. But I can't just start doing numbers, as much as I love them, without thinking of the big plan first. So I'm going to take the area of the deck and subtract the area of the hot tub. The deck is a W by W square, so W squared minus 35 because it's a 5 by 7 hot tub. Okay, and that's the answer. That's the area that's left over, W squared minus 35. And we would write that as W squared minus 35 square feet. And that's what you see at the bottom. Remember, square feet or square units of any kind does not mean we have to do more math. It's just a label. If that bothers you, you can write out feet squared or square feet or whatever, but don't think there's more math to do just because you see an exponent in the label. But all word problems do need to have the label. All right. In our next video, we're going to talk about multiplying monomials and polynomials.